Okay, welcome to the session where we are doing coding, how it is changing the world that we are living in. My name is Chandra. I represent Ajna Consulting Services over here. You can reach me over chandra@ajnacs.com. So that will be my mail ID. Now, just a brief introduction about myself. Okay, I have 21 years of experience or over 21 years of experience. Okay, so right out of college, I started working on Java and middleware technologies. So that's where I'm a specialist in. And I'm also a multi-cloud certified expert. I worked on AWS, Azure, Oracle Cloud, and Alibaba Cloud. Okay, so I have mentored and trained thousands of software professionals. I'm a supplier with Oracle and also with NTUC LHub. So I train people on Java, middleware technologies, and other related aspects of programming. Okay, so I worked with a lot of organizations as an enterprise architect, where I have helped them design, build, test, and deploy solutions at various scale. Okay, so I'm based out of Kuala Lumpur, so we are in the same time zone right now. So that's about a brief introduction about me. Okay, so let's get started with this presentation. So we are talking about coding now. I mean, I'm sure a lot of you are interested in knowing how coding will impact your life. Okay, so what do you need to know about coding? Okay, and what is in it for me? How does it help? Okay, and how will it change my world? These are oft asked questions in terms of what coding is. So let's answer a few of them over here in the next 1.5 hours. So first, let's get to the basics. Understand what a computer is. I mean, way back in 1600, the computer is being defined as something that can calculate. Even in the World War one and two, all those people who can compute fast have been called as computers. Okay, so they are computers, not accountants, not as anything else, but they were called computers. A computer is something that can calculate. So that's a very basic definition of what a computer is. Now, today in the world that we are living in, we are very connected. We have computers all around us, starting with your aircon, which can be scheduled to start at a particular time and or switch it off automatically, or auto control of the temperature. Starting with that to the Zoom presentation that we are getting connected through right now, everything is computerized. So computers are changing everything. There's not a single industry in the world that we are living in which is not impacted because of computers. Okay, so starting with food delivery systems, to online shopping, to the Zoom video call that we are attending right now, everything around us is affected because of computer and computerization. Okay, so in this world, it is always useful and beneficial to be computer literate. So having a fair idea about what a computer is, what can we do with the computers, and what can computers do for us. So that knowledge is very essential. Okay, so this is a definition that I found to be very interesting. Okay, this is not being defined by anyone who is modern. Actually, it's almost close to 200 years old definition by Ada Lovelace. She is considered to be the first programmer ever who has written a program, a set of instructions to do something. Okay, so that's what a definition of a computer is according to her. A computer can do whatever we order it to perform. So it can execute a set of instructions and do something for us. That's what a computer is, at the basic level. Okay, so now a lot of people have this question that, hey, I'm from engineering background, I'm from science, I'm from math, I'm from biology. Okay, so computer science is completely different and unrelated to me. Okay, it's something to do with technology. It is not something related to me. That's the assumption that a lot of people have about computer science. Actually, you know what? It's not. Okay, that's a wrong assumption. It's not. Computer science is not just about learning technology. It's not about programming. It's not about doing hacking or doing something superficial. Computer science is basically about logic, problem solving, and creativity. So these are the three words for me define what a computer is. So about logic, how do you solve your problems, and how can you be creative? Okay, so again, there's three words: logic, problem solving, and creativity. These are the three words that summarize computers. Now look around us. Everything, starting with ordering a taxi, to delivering food, to online shopping. They basically solved a problem for us. So all these are problem solving creatively and by applying logic. We have applied logic to solve problems creatively. So that's basically what a computer science is all about. Computers or computer science is completely about just that simple fact. Okay. Now, a computer, simply put, is hardware and software working cohesively to get things done. So you have hardware part of it, you have software part of it. Like human beings, human beings have the skeleton, and then we have the logic, reasoning, thinking power. So exactly like that, a computer is also hardware plus software. Okay. Now, what is the hardware? Hardware is all the physical components that you can touch, feel, hold, and access. So whether it is laptops, desktops, smartphones, or your tablets, all that is your hardware part of the computer. And then there is a software part. Starting with the Zoom session that we are currently using, the games like Fortnite, your MS Office, one of the most popular software around, and your typical browsers, which can be Microsoft Edge, Firefox, or Opera. These are a few examples of software. Okay, so this is what a hardware and a software is all about. Now, when you take your hardware and a piece of software, now that becomes your platform. Okay, so you have different platforms, like you have Macintosh platform, Apple, basically we call them as Apple's devices. We call them as Android devices. Okay. Excuse me. So the combination of your hardware and software is typically what we call as a platform. Okay. So for example, if you just see the simple scenario here. Okay. So, okay, let's start with coding. Okay, we have understood what a computer is, what a hardware and a software is. Now let's start with coding. What is coding? Coding is basically writing instructions to ask a computer to perform complex and repetitive tasks. You want a computer to do something like add two numbers, or multiply two numbers, or divide two numbers, or print something on the screen, or give some printout on the printer. So all that is your instructions. And when you assemble those instructions, that becomes your coding. You're asking your computer to do something. Okay, now when you take multiple aspects of this code and combine them together, that becomes your program. A program is a collection of these instructions that you have written. So one instruction is basically your code. And when you combine multiple instructions like that, that becomes a program. And when you combine multiple programs, that becomes a software. So in short, a simple assumption can be like you want to browse a website. Okay, you want to browse a portal. You need a browser. Like you open the browser, you send a request to the server sends a response back to you. Okay, so what you're using there is a browser software. A browser software in turn uses multiple small programs, and those multiple smaller programs are assembled through simple code that you're writing. Okay, so that's the relation between coding, program, and software is. So what we use is software. A software is assembled with programs, multiple programs, and each program is a collection of multiple individual pieces of instructions that you write. Okay, but wait, we just talked about a computer. Okay, and then we are talking about coding or software. Okay, so there's a small gap here. That is, computers don't speak human language like English, Chinese, Mandarin, Tamil, Hindi. They don't speak any of these human languages. They only understand binary languages. The binary language is zeros and ones. Okay, a computer is like a switch on your switchboard. Either you switch it on or you switch it off. Zero is off, one is on. A computer is always speaking only binary language. It's also called as a low-level language, or some people also call it as machine language. So a binary language, a low-level language, or a machine language. That's what a computer understands. But human beings find it very difficult to speak that language. Okay, so we speak, natural languages like English, okay, or other popular languages that are around. Okay, so just remember, computers is not easy. Programming is not easy. Okay, so what do we do? How do we have how do you communicate with the computer? Okay, if the computer don't speak our language, so how do we communicate with that? So there are choices that are available. At the end of the day, you're getting your hardware to do something for you. Okay, so you can speak in a language that your computer directly understands. That's typically zeros and ones, machine language. Your typical computer scientists are the ones who understand machine language. They speak zeros and ones and directly communicate with the hardware. Okay. Sometimes you can also use short abbreviated form of the machine language, which we call as assembly language. So you can talk to the computer using an assembly language. Now, an assembly language is something which is slightly different than machine language. A machine language wherein we speak all zeros and ones. An assembly language, we take these zeros and ones and define some abbreviated words. Define some abbreviated words like add, subtract, or multiply, and then we give some values to it. Now that becomes your assembly language. Okay, then because it is very difficult for normal non-computer background people to understand assembly language, so they have created something what we call as high-level languages. A high-level language is something, a few examples for that would be C, C++, and then you have Java. Okay, so these are the different types of high-level languages that we have in the world today. And here we use mostly the language that we use to communicate with one another on a day-to-day basis. So here the instructions are high level, and as compared to the machine level language, which is low level. Okay, here the instructions are natural English kind of languages. Okay, and we give instructions which are easy to comprehend, easy to understand, easy to communicate with the computer. Okay, so we have choice. If you want to write a program, you can write using a machine language, using an assembly language, or you can also communicate using high-level languages. Okay, but as we know, high-level languages are the most popular choice that we have. Now, what are the choices do you have when you talk about high-level languages? What are the choices do you have? So before we actually talk about what the choices we have, okay, we are speaking a language which is comfortable for us, that is high level. Computers understand low level language. So what happens in between? Somebody, or something does the translation for us. Now imagine if I were to communicate with you guys using Tamil, and let's assume that you speak English, I speak Tamil. So we need a translator or a person who can communicate in both the languages. So that's exactly what a translator is. A translator takes the instructions from high level language, which is human language, to what a computer understands, that is machine language or low level language. Okay, so that's exactly what we're doing here. So we're converting high level instructions to low level instructions by using a translator. Now, what kind of translators do you have? The translators are of two types. You have a compiler and you have an interpreter. A compiler and or interpreter. These are the two types of translators that we widely use in programming. Okay, so let's see a brief introduction about what a compiler is and what an interpreter is. A compiler basically takes one program. When you write one software, one piece of instructions, here you take all those instructions, translate them into what a computer can understand. That is your low level language. That's your low level language, and that's a one-time activity. So imagine you write instructions like take input from keyboard. So you take some input from the keyboard. Okay, you calculate, you perform some calculations and you print the result. Okay, these are the instructions that you have written in your program. These are the three instructions that you have written in your program. A compiler basically takes all these instructions and then translate all of them into what a computer can understand. So typically your zeros and ones. Okay, so that's how the translator is supposed to do its job. Okay, now this is a one-time activity and it's one program to another program. So one high-level program is what is you're taking as input and you're translating that into one low-level program. So that's exactly what you're doing. Okay, it's a one-time activity. Okay, and that's what we call as a compiler. Okay, most of the programming languages that we have in the world today uses compilers, are rather said to be compiled. Okay, rather said to be compiled. So let me just quickly show you a small example. I know we have not introduced Java to you yet, but I just wanted to show you here, what a compiler can do. So let's say this is, let's call this as hello world.java. Okay, here if I write a program, so let's call this as hello world. Okay, so I'm just showing you some instructions about how this is done. So you have, okay, small program that I'm just writing up here. Okay, now, hey, hi to everyone. Okay, so there we go. We take that and let's convert that into welcome to Smart Nation Press on coding. Okay, so it's what I'm doing here. So I've just written a small program over here. Now, what I need to do is I need to compile that. Okay, I need to compile that. So there we go. So that's just one-time activity. So you just write your compile command, and then you will be able to run your code. There we go. Welcome to everyone. Welcome to the Smart Nation presentation on coding. Okay, so that's done. This is a compilation. So you write all your instructions in one program, do the activity of compilation, and what you get is the code that can be executed. The code that can be executed, and that's a one-time job. Done, finished, end of story. Unless you do any further changes to the code, you don't have to do compilation again. You don't have to do compilation. This is just executing the code. This is just executing the code, and as you can see, you'll see the results right in front of your eyes. So that's typically how a compiler works. Now, if you see the other side of the coin, after the compiler, what's the next type of translator that we have from high level language to low level language? Now, that's typically what we call as an interpreter. So what is an interpreter? An interpreter does, something similar, but using a completely different approach. Like, for example, you write your program source code that can be n number of instructions. That can be n number of instructions. And when we use an interpreter, basically we are translating that high level language instructions into low level and execute them. But this will be a one step activity at a time. So you take only one instruction, translate, execute. Then you repeat the process. You repeat the process. Then again, take the second instruction, okay, translate, execute, and then go back to the source code. Take the third instruction, translate, execute, and then repeat the process. So this happens n number of times. This happens n number of times. As many instructions as you have in the source code, okay, it just keeps on repeating the same thing over and over again. Okay, now the languages that use an interpreter are typically called as your scripting languages. So there are two types of translation that can happen. One is compilation and the other one is interpretation. Okay, all programming languages use the compiler and all scripting languages use the interpreter. Okay, now just to introduce a few languages that are very popular in the world that we are living in today. Okay, sorry, just give me a minute. Okay, there we go. Now, languages, a few of them. Okay, as you can see, guys, there are thousands of languages that are available out there, but we're only talking about a few of them here. So let's start with a few of them. Like you have Java. I mean, I'm sure you heard about C, C++, a very old languages from 70s and 80s. Okay, then Python is very popular today, especially in Singapore. A lot of people are learning Python. And also there are a lot of opportunities on Python. Then you have JavaScript, the language that helps you to talk to the database, SQL. You have Ruby, you have Go, you have C# from Microsoft. Okay, you have Swift from Apple. Okay, you have Perl, Delphi, assembly language, as we said earlier. Okay, so these are just few examples of the languages that are very popular. Now, yes, let's see what languages are popular, as mentioned by the developer community. Okay, this is the latest update according to the November 2021 stats. Okay, these are the top 5 languages that are used in the world today. Okay, now, okay, pandemic has really helped Python to go up because last year around the same time, okay, C was the #1 language, okay, and Python was #2. But now there's a switch in terms of rating. Okay, Python has become the #1 language of the world. Then you have C, and then we have Java. Okay, now it doesn't mean that you have more experts on Python or most of the programs are written on Python. No, this is the preference as mentioned by the developer community about what languages do they use, which language do they think is the most easy to use. That's all we are saying here. Okay, you have Python, you have C, and you have Java. Then of course followed by C#, C++, and C#. So these are the top 5 languages of the world that we have today. Okay, now moving on. See, when you're writing applications, one of the biggest challenge that we have is, hey, we just wrote an application here, a small application. I mean, it doesn't do much, but yes, okay, it says hi to everyone. Okay, so we have written a program. We have compiled it and we have executed it. And we have seen the output. We have seen the desired output. That's fine. But most of the applications that we developed in the world today are what we call as platform specific. Okay, so what's a platform? Guys, as we said, the hardware plus the software is called as your platform. Okay, you have Apple, Mac. Mac is one of the popular platforms that we have in the world today. Okay, apart from that, we have Windows. Windows is the most widely used platform. Okay, almost 80% of the people who use computers use Windows operating system. Okay, so here the hardware, is from Intel, or AMD. You have RAM, you have hard disk, you have network cards and all that, but the software comes from Microsoft Windows. Okay, and on that, as I'm sure you are aware of, you have Microsoft Paint, one popular application on Windows platform. Similarly, you also have Mac operating system, which has Safari browser. Safari is a Mac specific browser. Okay, it runs on your iPhones, it runs on your iPads, and it runs on your Macintosh laptops or desktops. So right now, what I'm using right now here is a Macintosh desktop. I'm using a desktop and I have Safari here. Now, the other laptop that I have next to me is Windows. Safari is not available on Windows. Okay, so see, the problem is we have applications that run on only one particular platform. But in the world that we are living in, guys, we have a very mixed bunch of things. I have an iPad. Okay, I have a phone, which is, Android. I have a desktop, which is Mac, and I have a laptop, which is Windows. So I need software that can run on all these devices, not on one particular device. For example, Zoom. I'm sure all of us are using Zoom to join to this particular call. Okay, now it might be you might be connecting from your mobile device. You can be connecting from your desktops or laptops or tablets. Okay, so but the software Zoom works on all of them. Okay, now this is what we want. But unfortunately, there are a lot of languages that we have in the world today which help us develop applications, but those applications are platform specific. Those applications are platform specific over here. As you can see here, we're looking at platform specific applications. The applications, okay, you write your program, okay, but when you want to use a compiler, you have to decide where do you want to compile it. Do you want to compile it on Windows? You want to compile it on Unix, Linux flavors, or you want to compile it on Macintosh? Okay, so there are different platforms that are available. So your program gets compiled on a specific platform. So you get an executable that can run on only one specific platform, and you can run the application on that particular platform. So what you write is independent, guys. It doesn't matter whether it is Windows, Unix, or Mac. This code is independent of everything. But after that, the rest of the process, the rest of entire life cycle is platform specific. That means once you compile it on Windows, you can only run it on Windows. Once you compile it on Unix or Linux platform, you can only run it on Unix and Linux platform. Similarly, you can only run it on Mac if you compile it on Mac. So you write your code once, but then you compile it everywhere and anywhere. You just have to do that. Okay, so this was a big challenge in the early 90s. When computing became very popular, internet came into existence, this became a huge headache. This became a huge headache that we are developing applications that only work on a particular platform. They don't work on other platforms. So this was a challenge. Now, so what do you do when you're writing programs? Okay, as I said, we just drink some coffee. Okay, so that's where we're bringing in a cup of Java. Okay, so what is Java? Java is the language of focus today. I'm going to focus mostly on Java. Okay, so let's start with what Java is, and then we're going to go into what are the advantages and the USP of Java programming languages. Okay, now this story of Java started exactly a quarter century back. Okay, I mean actually it started 30 years back, but first version of Java is released in 1996. So as per the age of Java, Java is 25 years old. But the first initial 5 years were incubation period of Java. Okay, so the whole story started in 1991 when there's a small Silicon Valley startup called Sun Microsystems. So they were trying to develop, a software that makes normal television a smart television. See, the problem is most of the electronic devices, when we buy them, that's all, end of story. Guys, whatever features that we have for the device, they are limited and restricted to what they are at the time of purchasing. So imagine you buy a toaster. Okay, you buy a toaster, you go to the store, there's a very smart individual who's trying to sell you the toaster. So he or she explains all the features to you. You like the toaster, and then you bring it home. And that's it. Guys, the toaster is not, it cannot do anything more than what the guy has explained to you in the store. Okay, so same happens with your washing machine, same happens with your televisions. Okay, that too, especially in 1990s. Okay, when you buy a device, the device is limited and restricted to the features that we have when we buy the device. Okay, now these people at Sun Microsystems, they wanted to change that story. They wanted to make it smart. That means you should be able to write a software that can add features to the television even after you buy it. So once you purchase, you can bring it home, you can write a program that makes the television smarter. So that's the goal. Okay, so these people, they started working on a project. Okay, then what was the language of choice? They have chosen C++. They have chosen C++ because that's the most popular language at that particular moment of time. Okay, in the 1991, when this team, green team from Sun Microsystems, when they started on the project, okay, they used C++ to develop that smart television application. But then immediately they realized that there are so many disadvantages with writing a program in C++ because of its platform specific nature. So there are a lot of limitations. Like, for example, if you just see here, what happened? You have a television. So let's say you bring in a television from Samsung. You write your program, you compile it for Samsung, you can only run it on Samsung. You have a different television from LG, you have a different television from Sony, you have to compile and run it differently on each one of them. Now that was the first challenge they faced. So these people were like, okay, this is not going to help us. So they ended up developing a new language. And initially they called it as Oak. Oak was the language that they developed. Okay, because there was already a company called Oak, they couldn't use that name. They renamed it to Java because of, obviously the team was like fans. According to the rumors, according to the speculation, okay, the team were big fans of coffee, and Java beans, coffee beans were very popular. So they just called it as Java. Okay, so that's why the logo of Java is like this, the steaming hot coffee cup. Okay, so they started with Oak, and then they went into Java language. Okay, now Mr. James Gosling, he is known to be the father of Java. Okay, he, along with his team, have developed the programming language Java. Okay, so from 1991, they started working on it. And by 1996, they had released the first version of Java, that is 1.0. And today we are in 2021. The latest version of Java is version 17. So, 25 years, 17 versions, not bad. It's a good track record they have done. Okay. Then Java, it started as a simple programming language, but slowly it changed its nature. Even though we just started with one simple programming language, Java here, okay, later, which evolved into a platform. Okay, so they call it, this programming language is then called as Java SE. Java SE stands for your standard edition of Java. Okay, then they were like, Java is becoming very popular, very successful. And at the very same time, 91 to 96, the rise of internet has, helped Java. You can say that Java helped the internet development and internet helped Java's, success. Okay, so because internet was becoming very popular at that moment of time, they ended up developing one more edition of Java, which we called as Java EE, the enterprise edition of Java. Okay, then when you want to develop applications on your desktop, we have JavaFX. When you want to develop applications for the servers, we use Java EE. Okay, then you have embedded devices, your in-car entertainment systems, in-flight entertainment systems, your televisions, your mobile devices, and your card. Okay, all your access cards and smart cards, all of them. So there are different flavors of Java that help us develop applications for each one of them. Okay, so starting with servers, or rather what we call as enterprise computing, desktop, embedded devices, televisions, smart devices to smart cards. So there are different flavors and different editions of Java that is available for each one of those purposes. Now, Java EE is recently being renamed as Jakarta EE. Okay, just a point of note. So we're not going to spend a lot of time on this. So let's come back to this. What are the main features of Java? What's the reason for Java's success? Okay, so first of all, it was very simple. Okay, it followed the principles of object-oriented programming. Okay, Java was possibly the first language that actually focused on security inside the applications. And one of the most important features of Java is it is platform independent. You can write an application in Java. You can take that application and run it on any platform. Okay, so for example, the application that I've written here, this Hello World application, I can run it on my Mac, I can run it on Windows, I can run it on Linux. Okay, so that's platform independent feature of Java. Okay, then Java is standardized. Okay, Java is standardized. That means everybody, you develop Java application or I develop a Java application. We are sitting in Asia. Somebody develops it in Africa. Somebody develops in North America. All of us do the same Java application because Java is standardized as a part of the language itself. It supports distributed functionalities, and that's why it's very popular for enterprise computing, that is server-side computing. Java is robust. Java is the first programming language that focused extensively on multi-threading and automatic memory management. Okay, so these are certain features of Java. I mean, we're not going to go into deep dive of each one of them because this is not a technical session. I just wanted to introduce the terminology to you before we talked about how Java has changed the world. Okay, so meet Mr. Duke, the mascot of Java. Okay, so there's a logo and there's a mascot. Okay, this is the mascot of Java, okay, Mr. Duke. Now, let's see how Java is used today in the market. Okay, this is the research as done by in the year 2021. Okay, different industries are using Java extensively. So they've done a research about what would their preferable choice be. Like, for example, when you want to develop applications for mobile, what would be your preferable choice of language? Java is the number one in mobile application development because Java is the language that is used for developing your Android applications. So your Android, most of the applications that you develop on Android are written in Java. Okay, then for social networking like Facebook, Twitter, Instagram, WhatsApp, they use Java extensively. You're writing chatbots, Java is the number one in that. You want to process large amounts of data, which we call as big data. Okay, now that is done through Java. Okay, artificial intelligence, Java is number 3. Augmented reality or virtual reality, Java is number 2. Blockchain application development, Java is the number 2 in that. Internet of Things, like all your devices that are connected to the internet, your smart televisions or your smart ovens or thermostats, like Nest, all of that, Java is the number 2 choice. Okay, so Java is widely used in the industry. Okay, now moving on. Okay, what's the main reason for Java's success? Yeah, Java is successful. Like, guys, we are talking about it after a quarter century. That means it has to do something good. I'm sure it has done something great. So what are the list of reasons why Java is so successful? So to start with, okay, they borrowed from the best. Hey, that's something, you have to accept the fact. Java had an advantage of seeing all the languages that came before them and take the best out of each one of them. Okay, Java is, proposing and implementing the concepts of platform independent. And then it is still evolving. Java is one of those languages that is still evolving. Even today, after a quarter century, there are new versions and new features added to the Java programming language. So let's get started with that. Okay, what do I mean by saying borrowed from the best? Okay, let's take a simple example. Okay, so you want to make documentation. See, one of the biggest mistakes that people do when they write programs is they don't document well. So at the time of Java being developed, there was a language called CWeb, which had inline documentation. That means you can write documentation inside the program itself. Okay, so Java started supporting that. Okay, Java started supporting object-oriented programming from Smalltalk. Okay, Java started supporting bytecode virtual machine and bytecode just-in-time compilation from Smalltalk. I mean, maybe I'll be talking about virtual machine in just a couple of minutes. Just give me a minute. Okay. Then automatic memory management is something that is taken from, Lisp. Okay. Now, primitive data types, like, there are different data types that are available, like processing numbers, there's integer. Processing numbers with decimal values, you have double. You can do Boolean, true or false, or you can do, names, strings. All that came from C. Okay. And then, other features that are being borrowed from other languages. As I said, this is not a technical session, so we'll not be doing a deep dive into each one of these features, but the essence of the story is Java has borrowed from the best. Whatever are the best features that are available in different languages at that moment of time in the early 90s, Java has taken all of them and put them together into one single platform. Now, what about Java being platform independent? Yes, Java is platform independent. Okay, we have just seen a demo of this. You write a Java application, then you compile it with the Java Java compiler. And then you get what we see as a .class file. So for example, if you just see here, I have written a program just as a demo previously that I called it as helloworld.java. Now, when I compile it, I get helloworld.class. Okay, so that's exactly what it is. So you take a .java file, okay, and then we use the compiler, and the result of the compilation is the .class file. So this is a 3-step process. This is generally what we call as your source code. I mean, that's where you write your instructions. And this process is what we call as compilation. And then finally, we have, the bytecode that is generated. So the code that gets generated after compilation is generally what we call as bytecode in Java. So that's a 3-step process that we have in Java. So compiler has done its job. Now we have the .class file. Hey, most languages stop there. After you take the code, you compile, you generate the byte, whatever is the resultant code. Okay, this is end of, what a C program will do. A C program stops here. A C++ stops here. But Java doesn't stop there. Java takes this bytecode and go to the next step. And that step is this one. You have a Java virtual machine. If you noticed, I have done that. See here, Java, I got the .class file as a result of my compilation. As a result of my compilation, I got the .class file. Then I give the .class file to be executed to the JVM. And this Java command here is the JVM. So if Java C is the compiler, then Java is the JVM. Okay, that's a Java process that runs your code. So there is a JVM available for Mac operating system. There is a JVM available for Windows. There is a JVM available for Linux. So all platforms, you have a JVM. So you take your compiled code, that is bytecode, and you give it to the JVM. On all the platforms where you have a JVM, you can run the code. So if you look at the process here, what's happening. This is something that Java does very, very interesting. At this level, we don't care what platform you are on. Are you on Windows? Are you on Mac? Are you on Linux? No, it doesn't matter. You write your program, you compile your program, you get the bytecode. Then when you do the second step, that's when it matters which platform you're in. Okay, so here you have the bytecode, and that bytecode is given to the Java virtual machine, and that Java virtual machine should be there. I mean, think about your Android smartphones. You're able to run Java applications because your Android smart devices or smartphones also have, JVM. They don't call it as JVM. Google named it differently. They call it as Dalvik VM. But in short, it's a JVM actually. So your Java programs can run on Windows because there's the JVM for Windows. You can run them on Mac. You can run them on Linux, and you can also run them on your Android smartphones because there is a JVM. So wherever you have a JVM, you can run a Java program. That's it. Okay, so that's how Java is platform independent. It doesn't matter which platform you are developing the application. As long as you have a JVM, you can run your Java applications. So that's the beauty about Java. Okay, then this is, this functionality of Java is what we call as Ora. Ora is basically write once, run anywhere. You just write your program once, you can run it anywhere. Okay, so that's exactly what we're saying here. Ora, write once, run anywhere. So write your program, write your program, compile it, you get the bytecode, that is a .class file, and you'll be able to run that .class file anywhere. So that's Aura feature of Java. Okay. Now, hey, this is just a simple timeline. I've brought here. I'm not going to explain this because it'll take almost half an hour to go through all the features. But look at the evolution about how Java has evolved. Okay, so 1991 they started working on it. Okay, then 1996, 1991, they just went through multiple phases, but officially they released the first version of Java in 1996. Okay, then 1.1 was released, 1.2, okay, 1.3, 1.4, 5. Okay, then you have different versions of variants of Java that came into existence. Okay, and then 1.6 was released. Okay, now that's done. Okay, at this time, Oracle acquired Sun Microsystems. So the branding has changed from Sun Microsystems Java to Oracle Java. Okay, or Java from Oracle. Okay, now as you can see, after Java is taken over by Oracle, they've released 7, 8, 9, 10. Okay, and starting with 7, they've changed the complete process of Java. They have accelerated the development in Java. So you can see here in 2017 they released version 7. Okay, from here Java, there's a new version every 6 months. Every 6 months they're releasing a new version. So March 2018, September 2018, March 19, September 19, March 20, September 20. Okay, March 21, September 21, which is a couple of months back. We have a new version of Java, that is version 17. And already the plans are there to release version 18 by March 2022. Okay, now there are so many versions. I mean, right now, every 6 months we're getting a new version. So which version should you use? Hey, you should use the version, which versions is the community, is the market using? Now think about it. Which version should I use? Okay, so there are so many versions, starting with version 1 till version 17. So which one should I use? Okay, don't fret. Okay, so with every version, Java gives, LTS. That is your long-term supported version. Long-term supported version. Okay, so what does that mean? That particular version of Java will be supported for a very long time, minimum 6 to 8 years. Okay, so version 8 is the very popular version of Java. As you can see, 75% of the community who are working on Java are still using version 8. But version 11 is LTS and version 17 is also LTS. So people actually move from one long-term supported version of Java to another long-term supported version of Java. So 8, 11, and 17. That's the progression. In between, yes, there's progress happening, but they are not long-term supported versions. So the industry actually moves from one long-term supported version to another long-term supported version. So from 8 to 11, 11 to 17. That's why you can see already the community has accepted 11 version as the second best version to 8. And slowly people are moving to 11. But now, because 17 is also LTS, they have a choice of moving to 17. Okay, so this is what is happening in the versioning of Java, in the versioning world of Java. Now there are tools available through which you can develop applications in Java. Okay, what I have shown you is the bare knuckle method. This is your bare knuckle method where you open a editor, you write your program, you compile your program yourself manually, you execute your program yourself manually. Okay, this is basically what we call as bare knuckles. Okay, so without any tooling support. But there are excellent tools available for each one. There are multiple tools available for Java platform. Okay, so a few popular IDEs are like Eclipse is a very popular one. As you can see, guys, this is Wink Wink as a opposition to Sun Microsystems. Guys, Sun Microsystems, and then the product that is used is Eclipse. Okay, you can understand. There's something going on between them. Okay, so this is from IBM. Okay, this product was released as a tool from IBM. Okay, you have Sun and you have IBM. IBM's product is Eclipse, but it's now open sourced. The good news is it's an open source product. This is the most popular IDE on Java. Then you have IntelliJ IDEA from JetBrains. Okay, then you have JDeveloper from Oracle. You have BlueJ, which is very popular in academic versions of Java. And then there is NetBeans. Previously this was from Sun Microsystems. Okay, then Oracle took over, but now it has become Apache NetBeans. It is an open source product. I mean, all open source products, as we know, are free. Okay, Eclipse is free, NetBeans is free. Okay, BlueJ is free. Okay, but JDeveloper, there's a licensed version available for us, and IntelliJ IDEA, there's also a licensed version available for us. Okay, so these are the different IDEs that are very popular when using Java. Now, Java is widely accepted in the industry. As you can see, I've just provided a metrics for you. You can go through them at a later point of time. Okay, it is widely being used in financial and banking sector. Okay, it is used in government. Okay, 14% in finance, 24% in government and federal national. Okay, 10% in retail and wholesale. Surprise, surprise. Amazon website, Amazon.com runs, the backend runs on Java. Okay, then IT, construction, manufacturing, and telecommunication and ISP web hosting. 14% of that is Java. So Java is super popular in different industries. Okay, now it is also widely adopted. Okay, so I mean, this has been a recent survey that is conducted in 2019. Okay, when people have been asked, developers have been asked about choosing two languages as their leading application platform. Okay, top two, any two languages as their top two priorities. Java, beat everything else hands down. 83% chose Java, 46%. Second best choice is C++, and the third best choice is 32. Maybe in 2021 that numbers will be slightly different because Python has gained a lot of ground in the last 1-2 years. I'm sure about that. Okay, but yes, Java is still will be around the top tier. Okay, there's no doubt about that. Then, hey, we have understood that Java is widely accepted and widely adopted. So how has Java changed our world? Okay, now I'm going to give you 10 scenarios about how we are using Java directly or indirectly all around us. Okay, let's start with scenario 1, change 1. Okay, I'm sure all of you heard about the Minecraft game. Okay, so it is the best-selling video game of all time, with over 280 million copies being sold. Okay, so it is developed in Java. Minecraft was initially developed in Java as when it was an independent company, as a normal developer, Minecraft was developed in Java, but then Microsoft took over that company and then they released Java other platforms. Java is, Minecraft is still developed, working on Java, but there are other flavors of Minecraft also that is available. That's why now, there is Minecraft, and there is Minecraft Java edition. There are two flavors of Minecraft that are available. Okay, so as you can see, the first version came in 2011, and the latest version came in 2021, last week. Okay, November 19th, they released 1.18. Okay, Caves and Cliffs Part 2. It's the latest version of Minecraft that's been released. Okay, so that's where it started. Very popular application. So the most popular video game of all time is developed in Java. Second, NASA Whirlwind Java, is also developed in Java. Okay, what is this Whirlwind? I'm sure maybe few of you have heard about it, but a lot of people don't know about the Whirlwind. What is this Whirlwind? What Whirlwind is? What is the background behind the scenes story of your Google Earth, all your navigation applications that are out there, your Waze, Google Maps, Apple Maps, all of them use Whirlwind. Okay, Whirlwind is NASA's Virtual Globe API. Okay, it gives you information about everything, guys. Weather patterns, visualizing cities and terrains, track vehicle movement, analyze geospatial data, and educate humanity about the Earth. It's a non-profit organization, a non-profit application that is developed by NASA. Okay, so even if you want, you can go access your Whirlwind Java and write, develop a new maps application. Okay, where you can get weather forecasting or traffic information, or just educating human beings about the world that we are living in. Okay, so that's the second change that Java has influenced. Okay, so let's look at the next one. Okay, change 3. Okay, I'm sure all of us have heard about Mars rover. Okay, so that's being developed in Java. Okay, so Mr. James Gosling, he worked extensively on this, okay, in developing this technology and this particular application. So Mars rover, controller is developed in Java. Okay, then you have Deep Space Trajectory Explorer, or you have JMARS, that is mission planning analysis for remote sensing, and also JMoon for the moon, lunar planet of Earth. And then you have SMBT, small body mapping tool. All these different, space related applications are developed also in Java. Okay, so that's about change three that Java has brought in. Now, the most important change that Java brought into the world that we are living in is Android. Hey, Java, as we said, one of the core features of Java is security. So that's the reason why Android has chosen Java as its platform for application development. Even in the Android operating system, Java is used extensively, very widely. Okay, so as we know, Android has 85% of the market share in the smartphone world that we are living in. What are the other choices that we have? As of today, you have two choices. Predominantly, you have two choices. Okay, either you go with Apple, iOS, or you go with Android. Okay, so Android, 99% of the applications that are developed in Android are written in Java language. Okay, as I said earlier, when you write a Java application, you run it with the help of a JVM. But with Android, we use Dalvik virtual machine, DVM. They've just refactored Java virtual machine to Dalvik virtual machine. Okay, so that's the fourth change that Java has brought into the world that we are living in. Android, platform extensively uses Java. Okay, now give me a minute. Sorry for that. Yeah, here we go. What is the fifth change that is being done? Hey, we do search every day. Okay, we search Google, we search Wikipedia, we search for maps, we search for locations and places and people. Okay, one of the most popular application in the world that we are living in is your Wikipedia. Wikipedia has, almost close to 600 million hits a day in terms of accessing information. Okay, so Java is the backbone behind that. Okay, so there are a couple of products that we have, which is Lucene and Elasticsearch. These are two products that are available, and basically they help us to do text searching for text. Okay, so it can be combination of words, sequence of words, and random words that we can use for searching. Okay, so for you to do the search and get the results, but somebody has to do indexing of that results before on hand, and that's been done by Lucene as well as Elasticsearch, both these products. Okay, now these two products, okay, Lucene came in earlier in 1999, okay, and Elasticsearch came in 2014. Okay, so both of these products are the ones which support and which power Wikipedia for us. Okay, and there are a lot of database applications also, like MongoDB. Okay, it's just a popular example. It's one of the most popular open source database infrastructures that is available out there, and they also use Apache Lucene and Elasticsearch. Okay, so it is used in the day-to-day life without our knowledge. It doesn't come. Java doesn't appear to us on the surface, but behind the scenes, Java is powering the internet and powering most of the applications that we use on a day-to-day basis. Okay, now let's see Hadoop, for example. What is Hadoop? Whenever you want to do large volumes of data processing, we need big data technologies. And the most popular big data technology that is out there is your Hadoop. Okay, Hadoop is the most popular big data technology that is available out there. Okay, and it is the one that is powering Yahoo Finance, Yahoo Sports, and Yahoo Search, and also powering Facebook. Okay, now just to give you an example, okay, I'm sure all of you heard about New York Times. Okay, New York Times. So there is an Open Times website that is available. Open Times. That means New York Times is in operation for almost some 250 years. What they have done is they have taken the documents from the 18th century and 19th century, and they have completely digitized them. And for that, they use Hadoop as a technology. Okay, for converting articles in picture format into fully searchable, web pages. Okay, that is being done with the help of Hadoop. Okay, this is a huge project that New York Times has done using Hadoop. Same thing is done by Facebook. Similar activities are also done by Yahoo. Okay, so this whole big data technologies are developed in Java programming language. Okay, now, okay, Java is the enterprise backbone. Okay, now that's a very generic statement I've made here because I was thinking very hard about how to, convey this message, how Java is supporting your enterprises. So I just thought, let's make it very generic. Okay, think about all the companies that we use on a day-to-day basis, whether it is Google, your Facebook, your Twitter, you have YouTube, or you have Amazon. All these websites use Java for their backend programming. Like when you add an item to the Amazon shopping cart, when you check out that shopping cart, when you pay for it, and when you get the item shipped, Java is what the brains behind the application. I'm not talking about the front end. I'm not talking about what you see in the browser. I'm talking about everything that you don't see in the browser, but carries out on the server side. Now that's your enterprise backbone. Okay. Starting with when you make a phone call. Today, as I said, most of the telecom companies that we use, okay, they use Java as their main backbone application infrastructure. So when you make a phone call, calculating the bill for that. Okay. When you send a, when you make a Zoom call, okay, checking for your license information and checking for your, authentication information, like whether you're logged into Zoom or not. All that information comes from Java. And as you can see, in the Fortune 500 companies, 90% of them use Java. And there's a large community of developers that is readily available with Java technologies. There's over 9 million, developers. Okay, I'm sure that number is not accurate because I was searching for the number to get the latest stats. That's the best I could get, but I'm sure it's more than that today. This is from a couple of years old statistics. So we have a strong community of developers who are more than 9 million developers. And there are 900,000 certified professionals on the Java language, including yours truly. I'm certified on multiple versions of Java. Okay, so it is used as an enterprise backbone for telecom companies, for shipping companies, okay, for logistics, for stock exchanges. I personally worked with, New York Stock Exchange. I worked with BSE, Bombay Stock Exchange, okay, NSE, National Stock Exchange, Hong Kong Stock Exchange. Java is the backbone for that. Okay, we worked with a lot of banks, a lot of telecom companies, a lot of financial institutes, insurance companies, shipping companies, logistics companies. Most of them use Java as their backbone. Okay, so Java is the backbone for all enterprise companies. Then you have BioJava. Hey, now this is something which is very interesting. Bioinformatics in the world that we are living in today, as of now, November 2021, I'm sure everybody appreciates, the DNA sequencing and vaccine, calculations. Okay, so BioJava is a project that is being done in Java. Of course, the name itself is it's Java. Okay, so it is a library of bioinformatics. Okay, it helps you to generate or translate DNA sequences into proteins and other bioinformatic routines. This was completely developed in Java, which is widely being used by most of the drug companies of the world today. Most of the drug pharmaceutical companies of the world use BioJava as their core, DNA sequencing, algorithms. Okay. Then let's see something interesting. Hey, this is something that I just wanted to add. Okay. See, when you write programs, okay, now programming is a very tricky thing. Okay. I've been writing programs for almost some 24 years, starting from my college till now. I've been writing programs. Okay. Sometimes, you always get amazed about why something works and why something doesn't work. So programmers write to code. Sometimes it's very surprising that, you expect it to run and work. It doesn't. On the other hand, guys, when you expect that it will not work, you'll be surprised that it works. Like with anything else in life, it's a full of surprise, bag of tricks. Okay, why does it work? Why doesn't it work? Now, this is a challenge that I found it to be very interesting. Okay, in a real world company, like let's say you're a developer, okay, or you're a programmer. Okay, you write code. Once the coding is done, what do? You take the code, okay, and start, testing. Okay. Now, this is divided into two jobs. This basically gets divided into two parts. Okay, you have developers, okay, and programmers who write the code, and then share that code to a different set of people. Okay, these are testers. We call them as testers, or Q&A, quality assurance teams, QA teams. Okay, so they are responsible for testing your code. They are responsible for testing your code. Now, something works, very good. Okay, something doesn't work, very bad. So what happens? They test. If it doesn't work, they send it back. Okay, now again you change the code. Okay, you send it to them. It doesn't work. So there's a hip hop that's happening, front and back, that's happening between developers and testers. Now, this is true for every single language, every single platform. But you know what? They found a solution for that. And I'm proud to say that the solution was in Java, or the solution project that was done, how it has changed the world that we are living in, that is being developed in Java platform. That's called JUnit. JUnit is what we generally call as TDD, test-driven development. Test-driven development. What do I mean by that? Okay, so let me just give you a small example for that. See, normally, as I said just now, okay, your developers write some code, okay, and then share the code with your testing team. Okay, share the code with the testing team. So that's a completely different team. Okay, so this is QA teams, okay, where you have testers, okay, who test the code for us. If it works, well and good. If it works, it goes on. It goes on to the next stage. If it doesn't work, then you send it back to the development team. They do the changes, send it to you, and it keeps hip hopping or flip flopping between developers and testers. But instead of that, how about you do TDD? Okay, now this is called test-driven development. This is called test-driven development, where the developer, while writing the code, will do some kind of testing here. So they basically test the basic sanity of the code. Okay, test the basic sanity of the code. So, it should work at least to a certain extent. Hey, if developers stop developing and start testing, guys, who will develop the code? No, you can't test it completely. But guys, at least to a certain aspect, the basic functionality should work. That's what I'm saying. Basic sanity of the code should be, good. And for that, the developers use, a technique called test-driven development. And that's been made very popular by using this framework called JUnit. Excuse me. Now, this is so popular that one of the famous writers, Martin Fowler, has defined this as how JUnit has changed the world that we are living in. Okay, so it's a small piece of software called JUnit, which helps developers test their code before giving it to the corresponding teams, whether the sanity of the code is good or bad. Okay, so that's called JUnit, and that's completely developed in Java. As you can see, JUnit is for Java, developed in Java to test Java applications by Java developers to promote Java application quality. So that's, the 9th change that's very popular with Java. And then coming forward to what's the 10th change? Guys, how it's changing the world. I wanted this to be the 10th change because this, is a change that's happening in the last couple of years. But I think this will have a lasting impact for the next decade in the world of Java or in the world of programming. Because till now, Java is a language by itself, which will help us to develop applications, of different kind. But now Java is becoming a platform. It is no longer just a language. It is becoming a platform for other languages. Like, for example, you have GraalVM. Okay, now the GraalVM is basically about three things. GraalVM is about basically three aspects of it. The first aspect of it is it's a compiler that's written in Java. So understand that your compiler gets written in Java. That means you take application like Ruby, a JavaScript, a Python, R language. Okay, you have LLVM like C, C++, and WebAssembly. When you have all these languages, you need to compile them. You need to compile them, and that compiler is basically written using, Java. As you can see here, you have Graal VM Truffle, and then you have the Graal VM JIT compiler. So basically, a compiler that is written in Java. Okay, now that guy will generate obviously bytecode. As a result of this compilation, you get bytecode, and that bytecode gets executed on your Java Hotspot VM. That is your JVM, Java Hotspot VM or JVM. So that's where we are running the code. So in short, guys, Java is now, not just a programming language. It is a platform where you can write applications in a language of your choice. You can write applications in a language of your choice. Use Graal compiler to compile that into bytecode, and use your Java virtual machine to run that applications, anywhere. So whatever is the basic benefit of Java language, which is platform independency, is now being shared with the open industry. So it can run programs written in any language. So it is just a compiler written in Java, and it's super fast, and it has a great tooling support. So it is trying to plug, different platforms, different languages, and different aspects of programming together. Now, as you can see, from a traditional Java virtual machine to a native image, you have, 3x or 20x times faster, like 60 versus 60 seconds to 3 seconds. That's how the performance is being improved. So Graal VM is the future of Java being the platform for all other programming languages. Okay, so that's the most important change that Java is bringing to the world. Now, guys, it's not just Java. Java is just a means to, the end. Java is just a platform, it's a programming language, but you are the one who will have the power to change the world. Okay, so once you learn coding, once you have the ability to code, guys, you can use Java, you can use Python, you can use any other language. It is the power of human beings and the power of, what we can think about, that's changing the world. It's a logic, problem solving, and creativity. As we said at the top of the session, that is what changes your entire approach for application development. So whether it is solving daily problems like, having simple alarm clocks, to online shopping, to food delivery, to banking, to ATM machines. Okay, that is, how Java, how programming has changed our lives, solving daily problems or providing entertainment. Okay, you don't have to go anywhere to get entertained anymore. You have music, you have movies, you have videos, you have communication at the hand of your, in your hand, in your smartphones. Whether it is enriching daily lives. I still remember the good old days where we used to struggle to get a taxi. Guys, the taxi comes to you. You don't go to the taxis anymore. Very widely, biggest problem they solved, communication. As IDD calling was expensive. IDD calling was, very poor quality. But with applications that are being developed creatively, they solve that problem. Okay, better algorithms, whether it is for transport or traffic or search or financial and weather forecasting, we have algorithms. Guys, we can know when it will rain. We know when there are, when there is, what stocks to exchange, invest in. And finally, we have automation. Guys, everything is automated. You don't burn your food anymore. Okay. There are consumer electronic devices that are available. Like, guys, imagine you're having smart televisions, which can record the programs for you, which you can watch at a later point of time. Interactive voice response systems. Okay, or you have power backup for everything. Guys, there's no longer power failures that are available or that are interrupting our progress. Okay. Now, guys, the programs that work with your hardware, whether it is self-driving cars, okay, whether it is, advancements in biotechnology, guys, we should appreciate the fact that with the amount of computing power that we have today, we were able to develop vaccination so fast. And this is the first vaccination that is being developed within a turn of a year from the day the first cases were reported. Faster vaccines were made popular because of the ability to code. Advancements in, space technologies, advancements in, exploring the world. And guys, you have AI and machine learning. Intelligent bots are available all around us. Speech and facial recognition. No, that's becoming, that's making things secure. Guys, your smartphones can recognize your biometric fingerprints, can recognize your face. Now, all this is with the ability to code, with the power to change the world. Okay. Now, one of the nice quotes that I've ever heard about coding is something that I want to leave you guys with. It's the most valuable thing you can do for your career. Coding is not just a profession. Coding is the way of life. Okay. Now, Java is going to the cloud. I mean, people ask me this question. Hey, today we have cloud being the buzzword of the industry. No, but Java is already there on the cloud, whether it is Spring, GraalVM, Micronaut, or Quarkus. All this, Java is already there. Okay, so I want to leave you with one simple quote that's true for all developers. Okay, see, when you're having the bug at the back of your head of solving a problem, when you're working, when you're playing, when you're at home, or whether you're sleeping, that bug keeps you activated. Your brain gets motivated, stimulated, and then you'll be able to solve the problems of the world. Happy programming for everyone. Okay, so before we leave, I just want to highlight one thing here. At NTUC Learning Hub, we have a Java programming class that is available. Okay, so we call that as Fundamentals of Java Programming. This is IBF IT 1900 course. It's a 5-day curriculum where we do it as a virtual, live class. Okay, so the course is official course from Oracle University. It's an official, Oracle University course. So the courseware is directly available to you from OU, Oracle University. And we can also do the practices on Oracle University Cloud Service. Okay, now to encourage the community and also keep everyone interested, we are giving an opportunity to attend these courses during the weekdays as well as weekends and weekday classes. Both of them are available. So we do it on a 5-day, curriculum, which is spread across, 3 weekends, or we do it, in 1 week, flat out, weekday classes. Okay, so that's the course that we are offering for Java programming, Fundamentals of Java Programming. We have courses available otherwise on, other programming languages and technologies. So we have our friends from NTUC LHub right now, who will be able to answer or take your questions on, what are the courses, other courses that are available.